Okay, we'll be live any second. And we've got 5 minutes. We start in 5 minutes. And so during those 5 minutes, just until 8 o'clock London time, I will be doing sharing, things like that, getting it ready. So that at 8 o'clock we start. So that you know, so this session will be aimed at adults and older teenagers who will be helping younger learners. The content is, as usual, aimed at, will be suitable for 4 to 18-year-olds. And that's preparation for tomorrow. The actual activities will be tomorrow at 9 for 7 to 18-year-olds and at 10 London time for 4 to 6-year-olds. Let me just see, we'll share to a page. I'm too busy talking to you, not getting my sharing done, so I can start on time. And here we go. There we are. Now, today it's about measuring. It's measuring mass. What can be called weight. And you'll find out why we're calling it mass and not weight in the session tomorrow. Stay tuned. It's measuring mass and discussing weight. Right, now post that. Boom, that's been posted. Let's see. So far there's no other activity on there. And that's fine. So I'll open up another window. I've just shared it on the Facebook page, which is the Bubbly Maths Facebook page. In addition to the Bubbly Maths Facebook page is the, am I on it? No, I'm not, am I yet? Here we go, Bubbly Maths. So that's Bubbly Maths where we host these lives, and part of our objective in doing these lives is to help people learning at home, learning maths at home, whether it's now during crisis time or whether it's just normally, because people have problems with maths just during normal homework time, and home educators also often appreciate help with maths. Now, if I can find the live on the page, I've got 2 minutes left. Here we go. Now, what I haven't done yet is find the link. This is the perfect time, isn't it, to put the link in while we're waiting. Meter measures. No, got meter measures, done that. I suppose it's not called that. How heavy? It's called How Heavy. That's what it's called, How Heavy. Let's find it. How heavy. There we go. How heavy. Now you've got the link. I'm putting the link on. Got 1 minute to go. Oh no. Put the link in there. That link's in there. Now I'm behind the schedule because yeah, it's that's how it just seems to go with me. Let's see. I'm getting better. I'm improving all the time. I'm just going to put all the links for this evening in here. There we go. Boom. They're all there on the Facebook page, and now we'll put them on the Facebook group. And that's not a Facebook group. Facebook group is here. And it's 8 o'clock. We're about to start. I'm just posting the links on the top of the group so that you can, says she, with optimism. There's nowhere for me to post. There it is. There it is. There it is. I'm posting them right now on the group. And indeed, actually, I can actually post them in the comments of the live right now, which I hadn't thought about before for some unknown reason. Oh, we've got some entries for the got some entries for the toilet roll challenge. Toilet roll challenge happening in a minute. Right, there we go. Play that and start a watch party, and we're good to go. Post. Ooh, post. Right, getting all the postings posted, and play. Every time I think I've found it, it disappears. There, stay there, stay. Right, you stay there. You stay there, start watch party. Oh my goodness, we're just about ready. We're going to make this happen. Watch party, weight and mass. Weight or mass? I'm going to call it weight or mass. There you go, question mark. And start. And now it's going to ask me about it. Oh no, that's not what I meant to do. Never mind, it's done now. I'm not going to worry about it. Shared it in the group, not on my profile. Time for how heavy. So how heavy is what we're doing tomorrow. As usual, the first session, it's 9 o'clock London time, 9 in the morning. And that is aimed, I will be literally talking to 7 to 18-year-olds. The activities, if you can have ready, lots of different things to weigh. So for young learners, some examples are things to weigh is an egg, or that could make a nice mess, glass of water or a bottle of water, a pen, just lots of, just whatever you've got around the house, just simple things that can be weighed. And what things want to be, when I say a bottle of water, we don't want the actual measurements on them. So if you're going to have, if it's a bottle of water, it wants to be like the kind of bottle that you take out, a reusable bottle that doesn't actually say, well, actually the volume doesn't matter so much. What we're thinking about right now is the mass. And why am I calling it mass? Well, we'll tune in tomorrow and you'll find out why I'm calling it mass and not weight. So we're going to weigh the different things, and we're going to find out what their mass is. And that's, at least I'll talk about how to do it. And also we'll talk about, if you can, so if you've got scales, if you've got kitchen scales, and if you've got basculas, oh dear, the kind of scales that you weigh people, if you've got those, bring them along. They're also called scales, but so you've got the kitchen, here we go, you've got the kitchen type scales, and the word is not coming to me in English, hold on, Zoom. So we've got all these different types of scales. And if you don't have a scale, then bring 2 carrier bags and some kind of stick. Find a stick. I'll find a stick as well, because I don't have kitchen scales. And a lot of people don't have kitchen scales. In North America, they don't tend to use kitchen scales because they use kitchen scales because they use cup sizes. That probably goes back to the time when they were settling the Wild West and coming from places in Europe where people didn't have kitchen scales, and they just kept that, where people talked about the size of cups and cooked with portions of cups and spoons rather than weights and using weights. So we will actually improvise a little balance scale so that we can compare actual weights with estimates. We're going to do lots of estimating. So we're going to work together, and then other activities, we're going to work out some approximate. We're all going to have a guess at how much different things weigh, and then we're going to do a scaling activity, which is a recipe, which obviously involves weighing things and measuring things, and then we're going to scale it up. We're going to see how that goes. Now, there's lots and lots and lots of things here. I'm going to talk about a lot of things, but even if you just do one of those things every now and then, you think, oh, there's that measuring activity. Let's go back to that and just extract one of those. That looked like fun. Let's have a go at this. And the other thing is, for example, the estimating that we're doing. I always encourage you to have a look whenever you're walking around. I call it, oops, I found the mass, for shapes and just generally shapes. Just spot the shapes and oops, I found the mass. Well, same goes for estimating distances, and you can look at things that estimate their weight. Like if you see a train, well, how much does that weigh? If you see anything, a car, if you see something unusual, there's this amazing display in a place called Univers, in the universe. It's literally called Universe. It's a science center in Denmark, in this little island in the middle of nowhere. And the reason why it's there is because it's attached to a large organization that makes light bulbs, and they make all kinds of light fixtures, and they make power, the windmills, these giant windmills, that the power sources using wind. They've got a name for them these days. They're basically windmills. And so their way of giving back to the community is they've created this science centre. So you can go into the science centre, and one of the things they have, this is in the car park actually, so you can go and do that without even entering. So you can go and do that on a weekend. And they have a car that you can lift up. I can lift it up. A 5-year-old can lift it up with one finger. Boom. You can lift it up. And it's a proper car. It weighs a proper amount, but you can lift it up. So that's not exactly the theme that we're talking about tomorrow, but the point is, if we use our scales, we're going to make some artificial scales. It kind of works on it uses the same thing. We can work out, and you can work out how that works with the car. Maybe figure out how that works with the car, how someone can lift it up with one finger. Right, and then with that, so that's things we're going to do with primaries. Just estimate the weights of things, do our best to actually estimate what their mass is, and do our best to weigh them, or to find a way of narrowing down what their actual mass is. And then for lower secondary, we're going to do a different kind of measuring. We're going to get all the learners to collect data from their group, whether it's from their school group, if you're in touch with them, or from your family. Ideally, we can do 2 different types. We can do one where we're getting the weights of people that are the same age. That'll be one statistic. And then we can get weights of people of all different ages. And that would be a much broader statistic, but then you need more people. You need a lot of people. So you need to get as many weights of as many people as you possibly can, of all different ages. And would be, I suppose you wouldn't, ideally you'd know their age, but for this you don't have to know their age, but you can get some interesting, if you know, you'd maybe write it down how many were children you could estimate their ages, just so that you would have an idea of what it looks like. But for the main exercise, if you can get everyone the same age or approximately the same age, and so we're going to get all those together, not while we're doing the live tomorrow morning, obviously, but if you can start getting some now, fine. If not, you can do it tomorrow during the day. There's a lot to do here. You don't have to do it all. It's not about, oh, get all this done and that done and that done and the other done. This is all about giving you ideas of things you can do that are valuable, mathematical ideas that give you valuable experience and insights that stand you in good stead as you continue your educational career and in real life. So we're going to do that, and that's for lower secondary, so ages 11 to 14, and then above that, 14 to 18, what we're going to be doing is setting you a project. So I'll tell you about that. And right now, the idea is so you can be thinking about it. So this is, as I say, 14 to 18-year-olds, at any age can do it. My 5-year-old grandson can decide he would probably choose dinosaurs. So the idea is to choose a project, and you're going to relate the project to weight and mass. So the theme is weight and mass, as in, and we'll tune, when you tune in tomorrow, if you don't already know the difference, you'll know the difference. And so we want to be looking at the contrast between weight and mass, we've got some examples here. You can think up your own examples and just do a little project on it. Do some research, do some simulations if you can. So we've got gravity and space travel is one of the ideas. We've got health issues. We've got atomic mass. Why is atomic mass important? And then another one is mass and the law of conservation of energy. That's an interesting one. So what would, for me, it's kind of a no-brainer. Gravity and space travel. I'd be going there personally, but that's me. Oh, underwater as well. Underwater is another really cool one. What effect is, you've got the weight and the mass, and what effect does that have underwater? Another one I like is looking at metals. The weight and mass, and there's another, looking at precious metals and just any metals, comparing them, and just thinking if there's any others that aren't on here that I can think of that particularly excite me. Anyway, you choose things that excite you. Oh, sports, that's another one. You can, like, sports, just different sports, and you've got relating to weight and mass, and what sports. You can look at all different types of sports and all different environments and of sports, and we'll know more tomorrow about, maybe give you some ideas tomorrow about how to go about that. So that, there's not really any much more to it. It is definitely, again, another activity that can be a whole family activity. That is the objective with all of these. And so please get your scales ready. If you don't have any scales in the house, we'll be improvising with balancing. Now, if you've got a grown up and you've got two younger children, we can also balance on either side of a grown up if they're quite young. We don't want to damage anyone's arms. And so we're going to improvise a scale. I'm going to just come up with that because I don't have one. I can't demonstrate a scale, so I'm going to have to improvise one. Needs must, when human innovation is always at its best in times of strife. So so please do, if you're finding this group useful, please put a post on your Facebook with a link to the group. The link to the group is in the description below. I finally got my head together on how to do that. So there's a whole section of all kinds of lots of different links. In that comment below is also links to the YouTube channels. So there's the Maths Toys YouTube channel, which will have more formal, this is kind of me just chatting with you. This is more formal. Every single one of the Aiming High resources will have a video eventually. So they'll be going on, when we start churning them out, they'll be going on way more than one a week. And then there's the Bubbly Maths YouTube channel, which has these lives being uploaded, and there's other videos as well with what we do offline, which is using soap bubbles and balloons when we go in live, and we'll be in future using a lot of these resources as well when we go into schools. So and then there's the AIMSEC Facebook page, which has lots of little ideas, just little snippets, little memes, just to give you a moment of inspiration if you're stuck with maths, or you just want to reignite your brain, open your mind, have your brain open. My brain is open. There's a wonderful mathematician called Paul Erdos who used to say, my brain is open, when he was ready to think and create and research new ideas. And he didn't think there was any value in looking at a problem that you already knew the answer to. So if you're a true mathematician, then if you're working on a problem that you're struggling with, then you're doing real math. You're being a real mathematician if you are working on a problem that you're struggling with. The ones that, if you're just, now the one time that where practice is really helpful is learning your times tables, so that then you can be really fluent when you come later on in, or even you might already be there. Like myself, I didn't know my times tables when I was having to do things like algebra and calculus and things, and it was so much harder for me than it was for other people that knew their times tables, because I really had to struggle working out how the numbers all fitted together, whereas people that know their times tables, it's like, oh, that's obvious. For me, it wasn't obvious. I had to really work at it every time. And so it's hugely valuable knowing your times tables, and it helps you make connections. It helps you see patterns. So now I'm a little bit obsessed with getting, I am learning my times tables. For me, learning, I never stop learning, but actually memorizing things for me is a challenge, because when I memorize something, then it goes again, it disappears. It's there and then it's gone, which is a little bit, but if I do it enough times, then finally it sticks. So you might experience the same thing, but let me tell you, it's worth it eventually, because slowly but surely the mud sticks, and I'm always improving. I'm always learning something new and always improving. The problem is sometimes I have to learn the same thing again and again and again and again and again. So, but I never give up. Never give up. So I think that's everything that I wanted to tell you about. And oh yes, just to a quick recap on why we support AIMSEC. Apart from the fact that they're now providing us with these amazing resources, are providing the world with these amazing resources. Who knew? When I started supporting AIMSEC 11 years ago, I went out to South Africa because I met this amazing woman who had created, first of all, she created a website in the UK that's available around the world called Enrich. It's enrich.maths.org. And when she went to South Africa, she wanted to help with providing courses for professional development for maths teachers in Africa. She found that they couldn't use the Enrich website because they all didn't even have data in those days on mobile phones. It was just purely phone numbers and text messages. So she had to start again from scratch, and also they couldn't access what other data they had. They didn't have enough bandwidth to get stuff out of South Africa. So she started creating this website, all these resources, starting again from scratch really. And she's been doing that for years, for over a decade. And as a result, there's all these resources, and they're really high quality. They are thought-provoking. Like now she's creating these home learning resources which cover every age from early years to 18-year-olds, so school leavers. And they are low threshold, high ceiling activities, which means that no matter what level of attainment you've reached, you can get in and get your teeth into some part of it, somewhere in this home learning resource. You will be able to get your teeth into it, and then you can go up from there and stretch yourself to the level. Now you always want to be stretching yourself just that little bit. You don't want to be attacking something from high up that you just going to put you off because you can't do it. You don't have the underpinning knowledge and experience to do it. You want to go to the top of where you are with your underpinning knowledge and reach out for the stars, reach up, but you're only going up to the next level, and then the next level, and then the next level, and that's how you end up reaching higher pinnacles, by stretching yourself every day just a little bit. And if you're on that edge of stretching, that's where you're learning, that's where you're having exciting moments of insights that literally, where you get goosebumps. And if you get goosebumps, then you're experiencing the joy of learning, and that's what we're aiming for. So AIMSEC provide professional development for teachers in rural areas, in disadvantaged areas. We've got a lot of those teachers on this group now, which we're very excited about. And so you're all so welcome. the beauty, well, what we're going to be doing is we are going to be doing, every year we do a global, it's now going to be a global STEAM lesson. It's been a global maths lesson, but we want to make it, our very first one was maths and science, and we're going to make them maths and science every year, but we're calling them a STEAM lesson. So if you haven't heard of it, you've heard of science, technology, engineering and mathematics, STEM. Well, I've never liked that very much, and it's whatever, it's STEM. STEAM is science, technology, engineering, art and mathematics. So what I say is that art, creativity gives the power to STEM. And so it's STEAM, it's the science, technology, engineering, art and mathematics lesson. It's a global lesson on the 17th of September. Please book that date in. Let's be a half-hour lesson. It'll just be a PDF downloadable from the website, from the Bubbly Maths website. It should be on a few other different ones this year. Download it, register. If you register, you can send in your evidence, your numbers after the event, and we will send you a certificate of participation, and we'll let you know what the stats are. This year, coincidentally, and this was arranged before all this COVID was ever heard of, it is called Superstats this year, and it's the science and maths of health statistics, global health statistics. And it's in honour of Florence Nightingale, who was, and I didn't know this, a mathematician. She was a mathematician by choice at a time when girls did not learn maths, but she really wanted to. And then when she became a nurse, she used her knowledge of statistics to keep track of all that. That's how she conquered. That's why she's famous, because she used her knowledge of statistics to keep records, do literally experiments, do scientific experiments, as in she'd test different environments and see what impact it had, and cleanliness. And she one of the, I don't know if it was her but it was connected to so many little advancements. I don't think it was Florence Nightingale, but one of the examples of how statistics was applied to improving our health was that people were dying in, I think it was in childbirth, and by testing different environments and doing effectively using statistics the way it should be used, they worked out that it was actually the doctor's suits that were carrying the bacteria from one sickbed to another. So making a person who was already ill in one way, ill in another way, by taking the bacteria on their suits, hence why doctors now wear white coats. Doctors and everyone wears the clinical clothes that they change, whereas back in the day, they didn't even wash their hands. So because they didn't realize that bacteria existed. So all these discoveries were made by scientists and people using mathematics to work this out. So, and you can be sure that mathematics is being used at the moment to both study and overcome the COVID experience and control it. So, so Florence Nightingale was born 200 years ago. I think it was October the 21st, I think it is, around there. I'll find out again. Memory, not my forte, that's all right. It's in October, her birthday, and she'll be 200 if she was still with us, but she is still with us anyway. And she's and then we're also going to celebrate, so it's the Superstats on the 17th of September, celebrating the life of Florence Nightingale, and we're going to celebrate female mathematicians as well, and highlight a few of their stories. And there'll be lots of things to read and do, and history and present day mathematicians as well. And Tony doesn't know it, but she'll be featured as well. Okay, so I think that's it. I've done enough waffling. So thank you for joining, and let me just see who has. I haven't been looking at messages at all. It went from 4 minutes to 28 minutes, which means if there's anything in between, I don't get to see it. Is there anything on here? Sarah, hello, Sarah, Terry, and my brother, and Jan Baranowski, my wonderful mathematically amazing person from, if you're still watching from Poland, if you're still watching, Jan, this week's challenge is toilet roll challenge is to make a cube using a toilet roll. So what we want pictures, there's a post about it. And we want pictures and even better a video of you actually making it. If you post it on there, and then yeah, we'll just share. We want people to share their ideas of how to make a cube using a toilet roll and see what other ideas we can come up with next week. So we call it the toilet roll challenge. Got to be useful for something. I will see you 9 o'clock tomorrow morning for the session where I'll be talking to children. 10 o'clock London time is the early years session. So it's aimed specifically, I'll be talking specifically to the young learners. And then 8 o'clock tomorrow night, again, introducing the activity for the following day. Thank you very much. Right, I think that's everything. I don't see anything else there. No actual comments at this point. So I will end the live and I will look forward to seeing you tomorrow. Thank you very much. Stopping the live.